All right. Hello, everyone. Good afternoon. Good morning. Welcome. We're glad to have you all. While we let everyone trickle in, I'm going to do a quick introduction and then we will get started in the presentation. My name's Kayla. I'm here representing the Acelab team, and we have Giuliana and Jeremy here from ZinCo. So before I pass it over to them to get started with the presentation, I want to quickly jump over to Acelab. All right, so in just a moment, you should be able to see my screen. I'm here on Acelab. If you're not familiar, anytime you're looking to do some research, you can refer to the search bar at the top of the screen. If you haven't already used it, we have this new AI Copilot. It's a really cool way to do some product research and ask for specific questions using AI. However, if you're looking for specific manufacturers, all you have to do is type in the manufacturer name and click this button right here. And in this case, it'll bring you to ZinCo's page. So of course you can see this is ZinCo Canada. However, they do ship to US and Canada. Just want to make sure that's clear. We have Giuliana's contact information here for you as well. Some video as well as their products here for you to explore. So a lot of really great detail on each one of these product pages. You can click into any one of them. You can also save it to your firm library by clicking this button here. That way you have it there for future reference. So definitely check out their page when you have a moment. I will drop a link to this page in the chat in just a moment. But a couple other housekeeping items to go over. We will be doing Q&A today, so if at any point you have questions throughout the presentation, click that Q&A button at the bottom of your screen, drop in your questions, and we will get to as many as we can towards the end. We will also be doing a poll during the webinar, so you'll see that pop up in your screen about 3/4 of the way through the presentation. I want to make sure everybody knows that it's an optional poll. You don't need to fill it out if you're not interested in getting any kind of follow-up. However, if you are interested in getting in touch with Giuliana and her team after today, fill that out. We will send you an email within a couple days after the webinar connecting you there, opening that line of communication. It'll come from a no reply Acelab email address. So you can just respond directly to the email to get in touch with their team, or you can log into your Acelab account and respond to any conversations there. Last but not least, we will be doing a post-webinar survey as well. So any feedback you have is greatly appreciated. You can put that there. And that's everything on my end. So I'll pass it over to the ZinCo team.
Thanks, Kayla. Can you see our screen well?
Yes, I can.
Awesome.
Sweet. Yeah, thanks for having us. Great to be part of the Acelab group, and we're looking forward to getting into the details of green roofs. My name is Jeremy Wright. I'm more on the commercial project management and roof technicality side of things. So I do a lot of the estimation and on-site project management for jobs.
And I'm Giuliana. I'm the civil engineer on the team.
And so how me and Giuliana work is traditionally we operate as the consultants for large-scale commercial projects. So we are a design, supply, and consult company. So we used to be a full turnkey operation back in the late 2000s and up until about 2016. We are a supplier, and we basically work with architects, landscape architects, civil engineers, and building envelope engineers to specify roofing materials, but more specifically green roof materials, to create landscape spaces on top of waterproofing membrane, not just shallow, extensive green roofs. We do a lot of intensive green roofs as well. And so we're basically part of the project from start to finish. We start with the consulting and the design work. A lot of the engineering is managed by Giuliana. We'll go through the tender phase, and then we work with the installers all the way to the finish line of the project to make sure that it's installed properly. And then we also support the project by creating maintenance plans for the various types of vegetation on the project. We're located in Toronto and Vancouver right now, but we do consulting and ship to the States. And so we're very much looking forward to dealing with more North American projects in the future. So a bit of an agenda for today. We're going to talk about our types of green roof systems, which are built in place green roof systems. We're going to talk about growing media. Growing media is a very, very important topic in green roofs. It's kind of like the backbone of a good system. We're going to go through the discrepancies between extensive and intensive green roofs, stormwater management, which is Giuliana's specialty, and I'm going to talk about solar as well. So if there's any questions, obviously we'll get to them at the end. But yeah, lots of information. So feel free to reach out to us after the presentation if you have any questions as well. Do you want me to do, I can do this. Yeah, so when we talk about the different types of systems in the market, there's basically three types of systems. So there's a mat system. That's what we call a soilless system. So that's a pre-vegetated system on top of a retention fleece. Now, that's a very like North American way to do green roofs. It pretty much died out in popularity in the German European market in the late 90s. Although we can do soilless systems, if a customer wants to buy products from us to make a soilless system, you can do it. We would never recommend it. So we try to avoid a soil-based system, but that is a very popular system in the market. A lot of the reasons why we don't do soilless systems is because we call them roofs on drugs. So essentially, plants need soil and water to survive. It's food and drink. This is what happens to a lot of the soilless systems. They constantly need to be fertilized and they constantly need to be irrigated. Kind of defeats the purpose of the green roof. Green roof should be a self-sustaining system that needs minimal intervention from a fertilizer standpoint and an irrigation standpoint. This is why we don't do soilless systems. The second system that's very common in the market is the tray system. Now we have a lot of great competitors in the tray market space. These are plant people that do green roofs. Tray systems are very common because it's a pre-vegetated system that you can install in a 2 square foot material install. We can do trays, but we prefer not to. The reason why is because we want to be able to customize the system and build it in place. So we are a built-in-place system. That means that all of the material is brought to the roof and constructed, customized based on the vegetation type, the roof loading, the stormwater management requirements, and then the configuration of the roof. So a lot of roofs are irregularly shaped, so you don't have a perfect rectangle every time. That's why building the roof in place on top of the roof is the best way to do it. It's cost effective, it's bulletproof, and you can change and mix match our assembly buildups based on what you're trying to build. And so we like to customize, and that's why the built-in-place system is what we do. When we do a built-in-place system, every layer of our system is a direct representation of a subsection of soil. So what we're trying to do is comprise nature into a very shallow format. And so you have to do so with a few different layers. The first layer that we put on top of the waterproofing membrane is a root barrier. A root barrier is an impermeable layer. We've got two types. We've got one that's hot air welded seams, and that's for trees or anything that's got a rise in its root structure, really, really aggressive roots. And then our second type is a high density polyethylene sheet overlapped at about 2 meters or say 6 feet. And that's loose laid. That goes on top of the waterproofing membrane, regardless if it's an inverted or a conventional buildup. The second layer is a protection layer. So this actually protects the roof from mechanical penetration or any sort of damage in the future from the weight of the green roof sitting on top of it. And those two layers are the protection layers of this assembly. Now, when you look at the cross section of soil, the groundwater subsection is where a lot of the water is stored. And in a natural environment, the plants and these types of ecosystems that we're trying to replicate, their root systems are going down into the crevices of the rocks, trying to find that water source. And a lot of the times it's very deep. So what we do with our system is we have a water retention and drainage layer, which mimics the groundwater subsection of soil. This is like the sippy cup for the plants. It's also aeration for the soil. It's very, very important to have high aeration in the soil in order for the root systems to grow. And it's kind of our bread and butter when we deal with green roofs. How we separate the soil from that water retention layer is a filter sheet. And it's not like a typical landscaping fabric. It's a very, very fine filter sheet that holds the microparticles above it, but it allows for the roots to penetrate it so that they can actually get into the water storage layer below. And that's how that sippy cup effect works. The topsoil subsection of soil is represented in our system in the engineered growing media, and that can be different depths and different mixes and different heights, depending on what type of vegetation we're dealing with. But that's like the most important part for the root systems: high aeration, high aggregate, high drainage, but also a bit of water retention. And that's how these systems last really long. And then for the plant material, drought tolerant plants, always. We do a lot of shade roofs, but they always have irrigation, and we always try to use as much native plants as possible. Those are the ones that last the longest, with a mixture of sedums as well. So when we do built-in-place systems, and how we work from the consultant community is, you give us a design, you tell us what you want from an aesthetic standpoint and functionality standpoint for your roof space, whether it be the top roof is an extensive roof or a level 5 podium with trees. We take that information, we work as a team, decide which system is going to be best from a cost standpoint, shipping standpoint, installation standpoint, water standpoint, and then also configuration of the roof. And then we come up with a spec. It's always kind of customizable for the project, although a lot of our systems can be replicated across multiple projects. And then we come up with a spec and we design it for the plants. The first thing you got to think about with green roofs is, what do the plants need? And then you design from there. A lot of the times people look at what the roof needs and then they try to figure out what the plants need later on. You got to think about the plants first, because that's what everyone sees, and that's what determines if it's a successful system or not. So it's all customizable. Doesn't matter what height it is. It can be very shallow or it can be very deep. We have a green roof system for it, and it's all based on what the plant's needs are. Soil is a very, very important topic to talk about, because it's not topsoil, it's not compost, it's really low organic substrate. That's a good growing media. And we follow something called FLL. It's a very long German word that we're not going to try to pronounce, but it's kind of like the industry standard for a good green roof. Now, it's an international standard. It was derived in Germany to start, but it's a standard that a bunch of different suppliers came up together to make, to ensure that the green roofs were going to have a certain quality for engineered soil, to make sure that the green roof industry doesn't suffer from poor soils. It's really important for us to follow those guidelines. It's a tough guideline to follow, but it results in really, really long-lasting and sustainable green roof solutions. Because a green roof is not going to be sustainable if you have to fix it and you constantly have to keep it alive. It defeats the purpose. So the images on the left, there's a 35-year-old FLL growing media system, and it's kind of tough to tell, but there's a lot of aggregate still in it. The plants are doing okay, and it's surviving. It's draining really well. The plants are there, and there's no issues. The bottom roof is actually a roof that we replaced, and this was an organic roof that was installed with just compost and a triple mix. And as you can see, it kind of turns into like a silty clay or substrate mixture. And the image in the bottom right shows you that there's no space for the roots to grow. And that's why this roof failed. What happens too, when the particles start to shrink and there's no space for air, the system doesn't drain. So they become a huge risk to a building or an asset owner, because these systems kind of turn into swamps or bathtubs. And a really good example of this is a podium in downtown Toronto, 5 years old. At the inception of the project, the substrate was going to be flush with the top of the pavers. And in 5 years, this roof has degraded about 8 inches. And a lot of people will say it's compaction or wind erosion, but it's not. It's actually decomposition. So it's gone to a anaerobic state. So there's a lack of oxygen in the substrate. And what happens when you go into an anaerobic state in soil is these microbes start to basically thrive in an anaerobic state, and they start to consume the organic matter in the soil. And so that's why you see in a lot of old condos and a lot of old podiums, planters, the soil's kind of going down, down, down. You're starting to see the insulation that goes around the inside of the planter start to expose itself. And that's decomposition of the soil. So this is, you start with a cheap soil to install it. Everyone sees the price tag and say, okay, I'll go with the top soil on my podium. But podiums behave a lot differently than a ground level landscaping job. And so this soil starts to compact or decompose over time. You have to bring that soil back up to the roof this is a $300,000 fix, which could have been avoided if they had just bought a proper green roof soil. So we want to avoid this because it's not sustainable, and yeah, we just want to make things work and make sure they're bulletproof.
Okay, so throughout the presentation, we'll go through the 3 basic systems that we like to classify our green roofs with. So the extensive green roof, which you guys are probably very familiar with, are those top level, typically non-accessible green roof sections that just have minimum soil depth and a sedum species. So it's very low maintenance. We like to then classify a middle zone as a semi-intensive green roof, which we allow to have a little bit more of a growing media depth, which allows a lot more flexibility in the type of vegetation you can support. And then we go for our intensive green roof systems. These are our amenity levels that have transitions from walkways to trees to planters with different types of perennial plants and just a large capacity of an accessible space. So first off are extensive green roofs. Again, the ones typically that you don't access, but you need to meet some of your green roof codes. So this is our shallowest and most lightweight system. It supports only succulent-like species like sedums. Again, we like to try to keep them more installed in this system. This one shows an inverted buildup. So as Jeremy described the layers of the system, you'll see that we start with our root barrier, and then we actually put our insulation on top of it. Then we have a diffusion membrane on top of the insulation. So you really want to keep that insulation, allow air to go through it, but doesn't allow water to go through it, because we don't want to waterlog our insulation, so that reduces the effect. And so for planting methods, we like to have plugs, which are those little baby plants you see in the first image on your left. And then there's also an option for sedum mats. So they just roll out directly, like kind of like sod rolls. And then they allow for instantaneous growth, but sedums over a growing period will have that coverage that you need. So just as a little example on our installation process, first we start with this root barrier. We put this across the entire roof underneath both vegetation areas and vegetated free zones, whether they be simple gravel maintenance walkways or any type of accessible paver space. And then we go with the protection mat. So this is a conventional roof buildup. We go right for this more fabric-y layer, as Jeremy said, really to protect against the mechanical strain of the overburden for the green roof system. This again goes across the entire roof, underneath green roof, vegetated free zones, maintenance pathways, any type of amenity space. And then we have a drainage layer. We like to, again, install this across the entire roof, underneath all different types of greenery or hardscaping, because we want to have a consistent drainage layer across the entire roof. We want the water to fall anywhere on the roof and be able to access the drains. We don't want to have any type of impediences of that water movement, because we want to prevent that bathtub that you might be seeing on some of the roofs that you see with the greenery on them. And then we install our growing media. There's a lot of ways you can get the growing media up to the roofs, either large bags and then craned up or blower trucks. But if you can kind of see, there's a lot of like a red color to our growing media. That's the aggregate that we use in our growing media. And so the best thing about this is the aggregate in the growing media acts as a ballast. So this keeps all the layers talked about before down on the roof, nothing's blowing away. And then we can actually leave this over the winter periods, depending on your installation timeline. And then we can plant later on when it's ideal for the plants. So this can be walked on by all the other trades on your roof. You don't have to worry about too much coordination with construction timelines. And then after you plant the roof, when all the trades are done and the season is right for the plants. So this is an example where we did that plugs planting. So you don't have immediate coverage at the time of installation. You can see there's those pockets where we have some spacing in the plants, because we really want the plants to grow where they want to grow. We have some that are better for sun areas and some that are better for shading areas. So we really want them to compete, and then they can thrive in those designated areas. And then as you can see, over one growing season, they actually become pretty full coverage. So if your client is allowing for a little bit more timeline for that plant growth, this is a cost-effective option.
Yeah, and so similar to what Giuliana just mentioned about protecting the roof during the installation, that type of principle still applies for intensive roofs, and even more so. So the images that we're looking at right now, this is like a podium. This is a level 3 project, but every component that you see on this roof, including the hardscape, the Core-10 steel edging, the water feature, and the vegetation, is on one continuous drainage layer. And this roof actually has 0 penetration. So we're huge proponents of avoiding concrete doweling or concrete planters going directly into the waterproofing membrane. It creates a thermal barrier, and I'll go into some of those details in a sec. But this entire system has no penetration to the waterproofing membrane, and everything is built directly on top of our FD60 drainage layer as well. So what our kind of generic intensive system for like cost-effective and shallow growth is called a perennial garden. So it's very similar build up to our sedum system. But what we do here is you can see that we've increased the substrate to about 6 inches. So our definition of an intensive roof is basically anything a foot or above. A lot of different municipalities say 6 inches, but regardless, as soon as you hit 6 inches of substrate, you can start growing some pretty interesting plants. You don't need as much plant or substrate as you think. So what we really specialize in is lightening the entire landscape roof into a smaller green roof sandwich, and then doing so by adding a water retention layer. And you can see in our cross section here, it's called FD40. So that's about a 2-inch water retention board. So taller plants, deeper root systems, they need more water retention. And so we've increased the water retention through our drainage board. So this is an example of what a podium or a parkade install looks like for us. And it's tough to see from this image, but so this is a conventional roof. So insulation is below, but there's only 2 drains on this roof. This entire roof that we're going to build through this sequence of photos, there's no penetration to the waterproofing membrane. It's one continuous horizontal waterproofing membrane. And basically we were able to delete the concrete curbing into the waterproofing membrane through our drainage board. So 2 area drains, and you're going to see a lot of landscaping happen. So the first layer that goes down is the root barrier. Now that's the WSB 100. So that's a hot air welded seam. So it's continuous across the entire roof because we're going to put trees on this roof. The tree roots can grow, 2 times the size of its canopy. So you can't just put the root barrier in the planter. You have to put it everywhere. Whenever you approach any type of roof that's got plants on the roof, root barrier to us needs to go everywhere. The second layer that goes down is number 2, the protection mat. So root barrier goes down first, then the protection mat, and then third layer is the drainage board. And as you can see here, we've got little concrete blocks all in little squares around the roof. And so we call those concrete pedestals. And this is a leveling mechanism that creates a perfectly level and robust system for a planter to sit on without having to add all the weight of, say, like a aggregate or an HPB. And so we create these curbs on top of the drainage board to create that level surface and reduce weight. The fourth layer is the filter sheet. Filter sheet goes across, and that's going to go across, depending on what your buildup is, but it's going to go across the vegetation and the aggregate as well. And then the formwork that you see is where the curbs are going to go. And these curbs are going to get poured directly into the drainage board. So the detail that we're trying to avoid is this scupper detail. And when you see a planter wall that's doweled directly into the waterproofing slab, there's a few things that you're running into. So one, you're creating a thermal bridge. So you're losing energy through the building just because you're penetrating that insulation barrier. You're creating a potential bathtub because the scupper is going to be that path of the flow path for the water. It's going to be buried. And then the third detail you're dealing with is you're dealing with a very tough waterproofing detail. So where leaks happen a lot of the times on podiums or amenity spaces is the transition from the horizontal waterproofing membrane to the vertical. And so what we're trying to do is delete that vertical transition and keep it monolithic on a horizontal plane. And so how we do that is pouring the concrete directly into the drainage board. Now, people always ask about seismic and specifically in the West Coast, seismic dealings. And we have to typically stamp our own engineered drawings for this approach. But the benefit of this is that you're going to reduce the risk of the planters turning into a bathtub. your install rate is going to be, you know, at least 30% higher than a traditional detail, because the roofer's coming in once, they're doing one horizontal surface, and then the landscaper's coming back and doing all the drainage board and concrete work. And then you're also reducing the amount of drains that you need on the roof. So traditionally, if this was a planter that was dialed into the roof slab, you're going to have an area drain within the planter, and you're going to have an area drain in the hardscape. So when you do this approach and the water is continuously flowing through the drainage board, you can reduce those area drains by quite a bit. Typically, every area drain that you have on a commercial building adds about $15,000 of mechanical work. So that's a lot of savings. And how the drainage board works with the concrete formation is, because it's three-dimensional, the concrete actually takes the shape of the drainage board. So it's not like it's suspended as above, it's fitting into the grooves of the drainage board, and there's air pockets throughout it that allows the water to go through. So from an installation standpoint, this entire roof is built on FD40, including the water features, the planters, the hardscape, those concrete curbs, the turf, and the landscaped area. So one horizontal waterproofing membrane, one drainage board, and only 2 drains on this roof. And that's how we can make jobs a lot more efficient from a detailing standpoint and a constructability standpoint.
So the next topic we'll go over are what we like to call stormwater management roofs. This is ones where we like to add a little bit more water retention and detention to these systems. So just a little background, there's a difference between retention and detention. Retention is the amount of water that is completely stored in the green roof system and does not discharge into your municipal sewer system. So water falls on the roof, it gets stored in our growing media, our drainage layers, retention mats, and then it evaporates back into the atmosphere. And this is a little showcase of how the roots can actually access that water. You can see that they're really going into this. This is the south side of that filter sheet. You can see the roots are actually accessing that water. The next kind of stormwater management practice is detention. So typically you have an underground detention tank, and this is water that falls on your project site, is not actually retained by your greenery system, is definitely not retained in your paving system. And then you have to capture that water and then slowly delay its entrance into the sewer system. So what we want to do is move that detention space up into the roof level. So we have a detention spacer element that can go underneath the pavers, extensive all the way to our intensive systems. Again, we want to have that uniform drainage layer across the entire roof. So we want to have the same system be across the entire roof. So this spacer element is what provides that volume for that water storage. And the other aspect of a detention element is a control drain. So we want to mimic that orifice that you typically have on those detention tanks. So we have what we like to call a runoff limiter. So it fits on any of your area drains. It has an adjustable dam up height based on whatever your building codes allow for temporary ponding water on your roofs. And so once the water goes above that designated design depth, it just overflows. And then it also has an adjustable opening at the bottom, which we communicate with the civils to let us know what we need to set this at for the release rate off of the roof. And then so in combination, we're shrinking those underground detention tanks, we're moving that water up into the roof, and we're saving a lot of money in that aspect. So just as a little case example of how this works on a roof. So case example of a roof, 2% slope, you're actually only having water pond around the roof drain. So if you can see in the detail, you'll have that designated depth of water storage only at the drains. As you go farther and farther away, it actually gets shallower and shallower. So you're not really maximizing your blue roof potential. So what we could recommend is increasing that depth of that detention spacer element. But again, we have to work within the building code regulations. Or what we like to then promote is a flat roof. So flat roofs are a lot better for utilizing the entire roof space for detention. You don't have to worry about any type of the slope factors, any of those calculations that go around that. It's just a uniform layer across the entire roof. You know that there's going to be the same depth across the entire roof.
Yeah, and so kind of further to what Giuliana was talking about, like integrated engineering solutions. So on top of blue roofs, we also do solar as well. So with green roofs in general, a lot of people know them as like these kind of dormant, monochromatic looking green roofs that You know, sometimes they look really great, and sometimes, you know, depending on what you paid for, they look kind of crappy. So what we really like to do is we like to integrate either solar or water harvesting into the systems, because you can capture a lot more benefit from traditional green roof. So solar, which is, you know, really starting to catch its wind, but I know that the bill that just got passed in the States kind of just hammered all the tax credits for solar. So I'm not sure what's going to happen there. But solar is at a really important point, because economies of scale have reduced the cost of solar panels. So from a financial standpoint, it makes a lot of sense to use solar whenever you can. And when you're dealing with a project that has a stormwater requirement and an energy requirement, a lot of the times you're fighting for space on the roof. So, you know, we see lots of roofs where solar panels are one side of the building and green roofs on the other. You might as well just integrate the two, because the green roof itself actually can optimize the energy modeling of the system itself. So wind uplift is a huge concern with solar panels, which kind of dictates what type of degree you have to put your solar panels on. So when we do, we're full comprehensive design company. So our sister company, which is also a solar company, they do a lot of our energy modeling and layouts of our PV panels. But when we integrate the panels into a green roof, and this table is shown because we were actually able to increase the angle of the PV panels by using the green roof as a ballast, which increased the wind uplift resistance of the panels and effectively produced a higher return for the client. So utilizing the substrate and the green roof as a ballast for the solar panels can increase your wind uplift. And then most importantly, it's actually going to cool down your solar panels. And solar panels, you know, say you're a lot of the times, if you put a solar panel on top of a black roof, those solar panels are only going to be about 25% efficient of the total capacity for energy capture. And that's a byproduct of the amount of heat that's happening on those roofs. So 25% efficient is pretty low. And so with a green roof, you're actually going to increase it by about 5%. And 5% doesn't sound a lot, but when you're increasing something that's 25% efficient and you add 5%, it is actually quite substantial. And the green roof is effectively cooling the ambient air temperature around those panels through the natural plant biological processes of taking water up, storing it, and transpiring it into the atmosphere. So how we approach that is we actually use a non-penetrative solar base, and it's compatible with different racking. We do manufacture our own racking, as well. But ideally, what we're using is 4 to 6 inches of substrate and a distributed point load. So when you ballast a typical solar panel, a lot of times you're using just a cinder block, and it's a 2 square foot cinder block. With the green roof, and how we can increase the wind uplift efficiencies of these systems, is it's a 2 square meter solar base, and it's a distributed point load. So it's not just one specific area that's got a lot of weight to it. It's distributed over 2 square meters. And there's a lot of different ways you can do this. We actually have a system now that's in a vertical configuration as well. What we specify from a panel standpoint is always a bifacial solar panel. So that's something that's it's a panel that basically takes UV energy on the front half of the panel, and then it also captures energy on the back half of the panel for any sort of reflection off of the roof. And it's beneficial for the plants as well, because it allows UV to get through and let the plant sustain growth. But from a traditional installation, this is what it looks like. So drainage board goes down first. The solar panels are installed based on what the racking providers have spec'd out. Substrate goes in. The roof should not be planted until the solar panels are installed. You don't want the solar panel installers to walk over your plants. And this is a really remote island in Georgian Bay, which is a few hours outside of Toronto, extremely high wind uplifts. And the solar panel system that was considered before actually couldn't satisfy the wind uplift with just traditional cinder blocks. So the green roof actually supported the wind uplift. And this is going to experience 150-kilometer-hour winds and storms. And with 6 inches of substrate, we actually have 8 inches in some areas as well. It's going to be fine. And so it's really, really interesting approach to doing solar and combining the two, specifically in off-grid projects as well. This is like cream of the crop for us. We have a few projects that are specified with this. So this is a blue roof combined with a solar panel, this is, a triple threat in terms of green roofs, because you've got vegetation, you've got water storage, and you've got PV on top. There's never been a system that's actually been installed with this, but there are projects that will be installed in the next couple of years with the specification. But this is kind of the future for us in terms of what we want to do with roofscapes. We want to enhance the return on investment for the end consumer with the green roof, make those spaces work for them. And they're underutilized spaces on green roofs that could be capturing more water and also more energy. Yes, and this is the vertical configuration that I was talking about. So this is brand new to the market. This is a really interesting configuration because you're specifically in areas that have a lot of snow, for example, in the winter. When you design a PV project that has a lot of snow, you're assuming that there's going to be a decrease in energy capture in the winter months. With a vertical configuration for green roof and solar, you're basically foregoing any risk that you have for snow piling up and covering up your UV panels. And we're seeing a lot of studies. So for specifically the first one's in Oslo, 30% higher output compared to a conventional array in the winter. And that's just because the solar panels are not capturing any snow just in the vertical configuration. This is a really interesting configuration from a wind uplift standpoint and from a maintenance standpoint as well. It allows for the maintenance contractors that are going to be maintaining these green roofs to walk freely amongst the roof. And it also brings up a really hot topic right now, which is agrivoltaics. So the combination of solar and agriculture. And unfortunately, we haven't actually done an agrivoltaic roof in Canada or the US yet, but it will be coming. And we foresee that this is going to be a very, very useful tool for systems or projects that have high wind uplift, maintenance requirements, and a lot of snow. And this is how it looks in installation as well. So now this is what we work with our sister company, Sponge. They're a microgrid company, so they do a lot of energy management controllers. So we always include energy management controllers and an optimized layout in any of our projects, commercial or residential. Always have a battery backup as well. And it's not necessarily blanketing the entire roof with solar. It's designing a system that's optimized for the energy consumption of the building. As much as we'd like to sell more solar on roofs, a lot of the times the costs just don't make sense. So making the system smaller and more optimized makes a lot of sense.
Yeah, and just to save some time, we just want to let you guys know we do different types of green roofs as well. So we do more biodiverse green roofs, which are those like semi-intensive green roof systems that allow for more plant variety and animal variety. We have a lot of like bird habitats, insect habitats on these roofs. And then we also do slope green roofs. This is an example of a barreled roof, but we go anywhere from, we have projects done from 10 degrees to 50 degrees. And then we also do urban agriculture, so rooftop farms. And then just as a little conclusion, what we always offer for you, we really want to work as a sub-consultant for you guys, giving you guys all of our knowledge for green, blue, PV systems, and being able to stamp those solutions as well. So you guys have confirmed okay with the systems that we prevent, and then implementation. So the actual installation, the actual production of these materials that you guys are specifying. Thank you. Yeah,
that concludes it.
Any questions from the chat?
I was trying to find my microphone. Sorry. Yeah, there's actually quite a few questions, so we can go ahead and jump right into them if you guys are ready.
Definitely.
Cool. So one of the first questions is actually wondering if they can have a copy of this presentation. So is that something you guys are willing to share?
Sure.
Awesome. Yeah, we'll get you guys connected then so we can share the PowerPoint. All right. And then the next question is, I think something you already kind of talked about a bit, but maybe you can just confirm this. But somebody's asking if wind loads are an issue and how you address this.
Yeah, wind loads are a big issue. So wind uplift on a green roof, and Giuliana, she deals with this on a daily basis. So we deal with a lot of tower projects, very, very tall up, and they have a very low structural capacity. And so wind uplift, it's not necessarily a horizontal flow against the roof that you have to be concerned about. It's the uplift, and the uplift is the wind is hitting the building, skyrocketing up above it, and then when it hits the parapet, it creates kind of like a suction effect a couple meters in or a few feet in from the parapet, and it uplifts the system. And so a lot of our systems are a lot lighter than the wind uplift pressures that those roofs are going to exhibit. And so we have a bunch of different systems that we can combine into our sandwich of materials, including wind anchors. We utilize EcoRaster a lot. And then in the worst case scenario, you can actually just mound your substrate higher with our system based on what the wind uplift pressures are. And that's kind of the beauty of our system as well, because if we're not a tray, it's not one consistent system across the entire roof. We can mound up to different weights depending on what we need to do for wind uplift. So wind uplift is a huge concern, but we take care of all that for every project.
Thank you. All right, next question. I have heard that green roof extends the lifespan of normal weathering roofing systems below the green roof layer systems. If true, how long does the green extend the life of the roof system below?
Yeah, so it definitely extends the life of the underlying roof because you're basically protecting it with this green roof system, and it's not being exposed to that UV interaction. As for timelines, we like to say it doubles, sometimes triples. We have the oldest green roof that's going on 60 years now out in Germany, I believe.
Yeah.
Yep. And so when that one bites the dust, we'll let you know. But as of right now, we don't have an endpoint for our green roofs and the relationships with the roofs underneath them.
Awesome. Perfect. All right. Next we have, what kind of roof system is compatible with the green system? For example, BUR, traditional built-up roof, ModBit, modified bituminous,
Yeah.
EPDM, or other membrane systems.
Yeah, so actually, because we're not a waterproofing company, we're comfortable with any type of waterproofing membrane underneath it. Depending on what's specified, we might just change the type of roof barrier we're dealing with, and most importantly, the type of protection mat that we use. So we're basically compatible with every roof except for shingles. So we've done projects on TPO, PVC, EPDM, BUR, PMR, anything liquid applied, as long as the waterproofing detailing is like perfect. Doesn't matter what type of waterproofing membrane you're using. If it's a crappy install, the roof is going to leak. And so green roofs don't cause leaks. That's a huge misconception in the market. People think that green roofs are associated with leaks in roofs, but actually crummy waterproofing details are why roofs leak. But we're compatible with every type of system. We don't really care what we're building on top of. We just need to know what it is so that we can specify the proper assembly. And that's why we talked about customizing our systems and interchanging the underlayments. So virtually every type of waterproofing membrane can have a green roof on it. You just need a different type of protection layer.
Gotcha. Perfect. All right. Next we have, is there any special consideration needed for freeze-thaw cycles in colder climates?
Definitely, and especially with those blue roof systems, we're going to have that temporary ponding water. So you really want to get, as Darren was saying, we can work with anyone for waterproofing, but we really want to work together with them, especially for these systems, to make sure that the roof is going to be warranted and like know any recommendations they have for any type of temporary ponding on top of their membranes. So for the blue roof system, we highly recommend maintenance, like intense maintenance visits. So we have maintenance required for the green roofs and the plants themselves, but then also for the detention element. So that is not just the spacer, but also the drain. So what we like to do is we need to flush out any of that water that's being stored in there. Again, it should be out, but we like to do a little double check, make sure you open the drains, see if there's any water still coming out. And then what we do is we recommend if we can like even remove the limiter that's on top of it. So that's the best thing about having something that's not dialed into the roof slab like any other kinds of drain controls. You can actually pick it off, change any of the settings on it, and put it back on. And in the case for like a winter period, you can even just take it off because there really shouldn't be any water getting into that layer. But just in case there is, it'll be removed from the roof immediately.
Awesome. Thank you. All right. And next we have, how small of a project can ZinCo undertake?
No project is too small. We started on sheds. The first green roof I installed actually was a shed. We still do sheds. We just want to support people that want a green roof. We really don't care the size. I think people think that we're a massive company. We're just small and nimble. We do big jobs, but we've got a really well-rounded team on our in our company. So it doesn't matter what the size of the project is. We might not have as much time to focus on the details of a shed, for example, but you can buy in whatever size you want. We do small cuts as well.
Perfect, thank you. All right, and next we have, can green roofs and solar be combined on shed sloping roofs in residential?
So sloping solar and green roof, that's a tough one. We've done one. It's really tough to do that because when you have a sloped green roof, you have to create a shear support system. So that's for the growing media not to slide off. Now we've got a few different slope green roof systems, and Giuliana had mentioned we go up to 50 degrees. Those are expensive systems. Integrating the PV panel into that, it's doable, for sure doable. The costs are not going to be cheap, but it can be done. It just depends on how steep the pitch is. If it's a 30-degree pitch, it's going to be expensive. If it's a 10-degree pitch, you could probably use one of our traditional systems. It can be done, but yeah, it depends on the type of roof.
Got it. All right. And next we have, what is the recycled content of the products?
Yeah, so we use 100% post-consumer recycled content in those drainage boards. So they're more of like a plastic-like structure. And then all the geotextiles as well are 100% post-consumer recycled content.
Awesome.
We're able to like supply like lead documentation as well for any of these products. That's probably what the context of that question was in.
That's great. Yeah, thank you for clarifying. All right, but I think that's the last question though for now. Would you guys like to make any final notes or comments before we wrap it up today?
No, like honestly, we really appreciate the time. Yeah, and like me and Giuliana, we're more on the commercial side of the projects. Olia and Julia, they're our landscape architect and architect team. They're in Vancouver. And then Jordan is our botanist and soil scientist. So if you have different questions for different types of projects, it might not be me and Giuliana dealing with you, but we are here to help. And yeah, we're looking forward to working with everybody.
Awesome. Yeah, thank you for that. And as I mentioned at the beginning, if you filled out the poll, we'll get you guys connected over a conversation in Acelab. So you'll get an email with that. You can respond directly to the email, and Giuliana and Jeremy will get you connected with the right folks to get your questions answered. So definitely look out for that email. It's a great way to get some further questions answered. And yeah, thank you for all the great questions today. And thank you, Giuliana and Jeremy, for the really great presentation. We hope you all have a wonderful day.
Thank you.
Thanks. See you.